Okay, we're going to consider binary numbers for computer science. So, computers process all data as binary. Binary is a number system which deals in only ones and zeros. We call it a base 2 number system. Now let's think about that. So decimals, what we deal with every day, and that's base 10. So this means if we have the number 261, we've got the units, we've got the tens, and we've got the hundreds. The units column is, if you think about the units, what does that mean? That means that's number 1, and we times that by 10 to the power 0, which is just 1. 10 to the 0 is 1. 1 times 1 is 1. 6 is 6 times 10 to the 1, which is 6 times 10, which is 60. And the 2 is 2 times 10 to the 2, which is 2 times 100, because this is the hundreds column, which is 200. So if we take 200, add 60, add 1, we get 261. That is the number system which we deal with, the base 10 number system. Now, the binary is base 2. So let's think about if we had 2 to the power 0, that is 1. 2 to the power 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the power 4 is going to be 16. 2 to the power 5 is going to be 32, and so on. So you can see in the base 2 number system, each of these digits is being doubled each time. And this is the binary number system. So let's think about a number in binary. Let's think of a 4-digit number in binary. So let's think 1, 0, 1, 1. This would be a number in binary. All binary is just a long list of ones and zeros. So let's put this into our grid. So just in the same way as if you were dealing decimal and you had a number that was in the thousands, you would put the thousands in the thousands column, the hundreds in the hundreds column, tens and tens column, units in the units column. We do the same idea here. So there's a 1, 0, 1, 1. What does this mean? So where we've got a 1, so there's 1 here, this is in the 2 to the 3 column, we have an 8. 0 here, so we don't have anything here. So it'd be plus 0. 1 in this column, so we've got a 2. So this column here is 2 to the power 1. 2, and then we've got 1 here, 2 to the power 0 is 1, so we add a 1. So we've got 8, add 2, add 1 is 11. So in binary, this number is the same as 11 in decimal. Now, how would we take a number? Let's take the number 55 and write it in binary. So let's look here. We'll look here and we say 32 is the number we've got here. Can we put 55 into 32? Yes, we can. So we'd put a 1 here. And then we would take the 55 and we would minus the 32. So that would give us 23. Can 23 go into 16? Yes, it can. So now we take the 23 and we minus 16. And that gives us 7. Can 7 go into 8? No. So we put a 0 here. It can go into 4. So we put a 1 here. And then 7 minus 3. 7 minus 4, sorry, equals 3. 3 can go into 2. And so then 3 minus 2 is 1. And so we need a 1 here. So 55 in binary is 1, 1, 0, 1, 1, 1. And you can keep doing this for ever increasing numbers. You just have to add 2, then do 2 to the 6, and so on. And you keep going. And you'd end up with a long string of binary numbers. So I hope that helps.